Alright, in this video we're going to practice naming alkanes, alkenes, alkynes, alcohols, aldehydes, and ketones. So we're going to start with a few structures like this. Go ahead and pause the video, give naming them a shot, and then come on back and we will walk through them as a guided exercise. So I'll give you a chance to pause here if you'd like. Alright, well, let's discuss naming these molecules. So, this one on our left, there are many carbons and hydrogens, and what we find is there's a double bond. So this is an alkene. So, if I have a double bond, I must have that double bond, if it's my main functional group, have as low a number as possible for the first carbon in it I run into. So I have a couple endpoints that I could start counting from. But if we start over here as carbon 1, that's going to be carbon 2. And so from all the endpoints, this has to be where we start, because that will give us the lowest first carbon for our functional group. It's going to make the next one carbon 3. And then I have a choice. If I go to the right, I have 4, 5, and 6. If I go to the left, I have 4, 5, and I can go to 6 down on the methyls, or I can go 4, 5, 6, 7. So our best route is that 7. So it's going to be carbon 4, carbon 5, carbon 6, carbon 7. So this is a hept, and it's a heptene at the 2 position, so it is a hept2ene. Well, it's going to have subgroups. I have carbons that aren't part of the main chain. So over here I have a 3-carbon group. 3 carbons is a prop. It is a subgroup. It is not part of the main group, so it is a propyl. And it is at carbon 3, so it is a 3-propyl. Over here I have single carbon groups, so these are meth. They are subgroups, they're not part of the main chain, so they are methyls. And there's 2 of them, so really I have a dimethyl, and they're both on the 5th position. And so that's going to be a 5, 5 dimethyl. And so if we bring all those parts together, methyl is alphabetically before propyl, so it is a 5, 5 dimethyl 3 propyl hept2ene. And so that is how we name our alkene. If we want to go over here to our alcohol, you'll notice it has a very similar carbon structure. It's missing the methyls, but it has the long chain, it's got the 3 carbons up, it's got the 2 down. But now I'm dealing with alcohols, OHs. Alcohols are my main functional group here, and I need them to have as low as numbers possible for the first one. Well, I'm going to use 2 different ways of numbering. We could call this carbon 1, 2, 3, 4, 5, 6, or I could have gone 1, 2, 3, 4, 5, and 6. Either way, our alcohols are attached to carbon 1 and at carbon 6. So one of them gets as low as can be, and the other just goes where it has to go. We have to count in order of numbers, and so 6 is where the other will be. Well, if we think about the carbon chain real fast, though, we had 1 carbon, 2 carbon, 3 carbon, and what we saw in our last problem was 4, 5, 6, 7, and in fact, I could have gone from up above. Where is it? If instead we had taken a route and said 1, 2, 3, 4, 5, 6, 7, 8. I could have had an 8 long chain. But that chain does not include both of my alcohols, and I have to include my functional groups if I can. So even though it gives us a shorter chain, I actually need to go the 6 carbon route that connects my 2 alcohols. And so which route to pick from that? Well, if we start at the bottom, as you had, and say 1, 2, 3, my subgroup, that since we're not using that as our main chain, my subgroup comes at position 3, where if I had gone from above, 1, 2, 3, 4, my subgroup would have been at position 4. So in both cases, my alcohols are at 1 and 6. But the subgroup shows up at an earlier number from one of these directions. So that is the direction we have to go. We are going to start here. And so this means it is a hex for our main chain. And they're all single bonded carbons, so it is a hexane. And I have alcohols at the 1 and the 6 position, so it is a diol. There are 2 alcohols. I then have a 1, 2, 3, 4 carbon chain, so that's going to be a butyl chain, and it's at the 3 position. So there's a 3 butyl hexane 1,6 diol. And so this is how we would name a di-alcohol. When you have multiple of a functional group, important note from this one is that sometimes, in order to get all of your functional groups, you have to pick a shorter chain than the max possible chain. But the functional groups are more important. So you pick the longest chain that contains all of your functional groups. Alright, so here are an aldehyde and a ketone. Go ahead and take a minute and try and name these. And then come on back. To name them, let's go through and talk them out. So, let's start over here with our aldehyde. So we know it's an aldehyde because it's a double bond to oxygen and the carbon goes to a hydrogen. And so this makes it an aldehyde. This one's a little bit of a trick because, well, I've got an aldehyde and it's naturally at the 1 position. Which means if we start going down the chain, here's the 2 position, and, oh, that's a ring. We can't number through a ring. There's no end to it. So that ring, well, we can't have a 3 or 4 or 5, 6 or 7 because, well, there's no end. We can't count off to the end. When you have a chain lead into a ring, you stop. So what does that ring become? Well, it's a subgroup. What we really have is a 2 carbon chain and a subgroup in the same way that if you had a methyl or a ethyl or a propyl. Well, this time I have a 6 carbon subgroup. It's in a ring, so it is a cyclo, and then hex for 6 and YL for subgroup. So cyclohexyl. And it's at the 2, where's it attached? It's at the 2 position. So you can actually have ring systems be subgroups. And that's what we're actually saying here. So we have a 2 carbon main chain with a ring of 6 carbons as a subgroup. Well, if I have a 2 carbon main chain, that is an F. The carbon bonds are single, so it is an ethane. And it is an aldehyde, so it is an ethanal. Transport that down here. Ethanal. So a 2-cyclohexyl ethanal. Now, you can put, normally for numbering we do, you can put in the number, you can say there's a 1 al, but since aldehydes have to be at number 1, if there's only one of them, it is often left out. And so having this be FN al is completely acceptable, and in fact, still to this day a little more common. Jumping over here to the right, we have our ketones. So how do we know they're ketone? Well, on carbon double bond to oxygen, and then the carbon goes to 2 separate carbons. In fact, they both do that, 2 separate carbons. So ketones are my functional group, and I have to pick a chain that hits my ketones. So even though, if I wanted to follow it, I could in theory say 1, 2, 3, 4, 5. I could have a 6 carbon long chain. Well, the reality is the only way to hit both ketones is to pass this shorter chain. So 1, 2, 3, 4, 5, or we could have said 1, 2, 3, 4, 5. Either way, the 2 and the 4 are where my ketones are, and the 3 is where my subgroup is. Well, I have a subgroup at the 3 position. It is a propyl. And I have ketones at the 2 and the 4. So the main chain is 5, so it is a pent. They are single bonded carbons to each other. It is a pentan. And then we have a 2, 4 dione. So ketones are own. I have 2 of them. Put my 3-propyl out front. It is 3-propyl pentan 2,4 dione. So this is how we would name this ketone with multiple ketones on it. Alright, in terms of a little bit of alcohol, aldehyde, and ketone naming, I hope that practice was helpful.